Very good evening, friends. Hope so. I'm audible. Okay. So today, my dear friends, we'll be discussing about we'll be taking some of the questions in geography, and we'll be discussing about the basic way of writing an answer. See, one thing, as I repeatedly used to say, that there is no one way of writing an answer when it comes to mains examination. Okay. Only thing is that every time I have to understand the question. I have to see that how many, say for example, hidden questions or say for example, subdivision in this question, most probably I'll be having it. And you can divide it and rationally you can allot, say for example, the respective word limits for the same. So first and foremost, as I repeatedly say, somewhere try to see how many sub questions are there within a single question. Okay. And we know the word limit. If it is for a 10 marker, we are supposed to write 150 words. Approximately in your UPSC mains answer scripts, right? A person with a normal handwriting and normal font size, normal spacing between the lines, right? Normally, we perceive that in one page, approximately, you can write 100 words. So 150 words approximately, you have to write it for 1.5 words. And see, if you're bringing diagrams, whatever the space you are utilizing for this diagram, assuming that this diagram is a right-sized one, right-sized one in the sense neither it is too big nor it is too small. If it is a right-sized one, and whatever is the, say for example, space you are consuming for that particular diagram, that will also be regarded as what words. For example, assume, right, with a combination of diagram and say for example, my writing as paragraph, right, paragraph or paraphrasing, right, whatever it is, right. If at all, if it is coming for 1.5 pages, it is considered that I have written for 150 words. Okay. Right, my dear friends. So with this, we'll get into the practice questions of today, right? And before getting in, just a piece of information. A comprehensive batch on sociology optionals will be starting on 31st of July, right? So somewhere just a piece of information for you. Right, my dear friends. Now, today I have just taken 7 questions, right? 7 questions. And of course, what I have just given you, these are the basic facts, right? Very important facts, I will call it. It's not necessarily that these are the only facts what you have to write if at all such a question is asked in the examination, right? I'm just giving you a gist. Okay, right. Right, my dear friends. Now, first I'll just start with this very first question. And one more thing, say for example, this Pacific Ring of Fire or this plate tectonic theory, right? Somewhere I understand, once in 2 years, we have one question on an average which is asked from this plate tectonic theory. Even when I talk about Pacific Ring of Fire, very recently also we had one question, right, asking for circum-Pacific belt, which is otherwise called as Pacific Ring of Fire. Accepted, right? But somewhere what I understand, repeatedly they ask the facts associated with this plate tectonic theory or plate boundary. Among the different plate boundaries of the world, the most important continuous plate boundary of this world happens to be the circum-Pacific belt. Okay. Otherwise, you call them as what? Pacific Ring of Fire. So, what exactly this question? This is a direct, straightforward question. What do you understand by Pacific Ring of Fire? See, open-ended question. Okay. If at all, say for example, if they somewhere, right? If at all, if they're somewhere specifically asking about few aspects, I have to revolve around it. But still, when talk about what do you understand by Pacific Ring of Fire, let me tell you, my dear friends. When you come across this word called as fire, fire in geomorphology normally, say for example, somewhere relates to volcanoes, right? It relates to volcano, right? So if that is the case, somewhere my central focus or the primary focus should be revolving around this volcano. Okay. So here I have not mentioned whether it is 150 words or 250 words, right? Depending upon the question, somewhere we can add more informations and less informations, right? Right, my difference. So what exactly is this Pacific Ring of Fire? Somewhere I'm just defining it. Okay. First, right? If at all, if it is open-ended, always it is better to start your answer with somewhere describing or defining what exactly the process or the location is all about. Okay. Here, I cannot define it. Rather, I can describe it. Okay. The Pacific Ring of Fire is a major area in the basins of Pacific Ocean where a large number of earthquake and volcano eruption occur. Though I use this word called as earthquake, my primary focus should be revolving around volcanoes. So even the data, I'll be giving more data about this volcanoes because, as I already said, it is called as Pacific Ring of Fire. Right? Again, I repeat, fire generally refers to what? This volcanic activity, if at all, if it is asked in geomorphology. Okay, right, my dear friends. Now, somewhere I have to describe this region. So it is associated with nearly continuous series of oceanic trench, volcanic arc, and of course volcanic belts. Right. And if I'm just putting in numbers, roughly, right? According to the old Wikipedia information, somewhere we say roughly it has somewhere around 452 volcanoes. Generally, I have just given, but to be very precise, this 452 includes only active and dormant volcanoes. Right? Extinct volcanoes has not been considered when it comes to this number called as 452. Right? Now, as I already said, this region is sometimes also called a circum-Pacific belt. You call them as a Pacific belt, circum-Pacific belt or circum-Pacific zone, right? Already the old question paper, they have already asked this question, right? Describe or somewhere describe about this circum-Pacific belt as such. Okay. Now, regarding some of the other facts, my dear friends, volcano, somewhere I've just given you this fact. And about 90% of world's earthquake, I'll add one more word here. World's large earthquakes occur along this region of Ring of Fire. Right? Somewhere, say for example, right, just not 90% of earthquake, 90% of large earthquakes, right? They occur along this Pacific Ring of Fire. Okay. And my dear friends, not only that, when I just talk about the number of volcanoes what we have, nearly what we understand, this region almost accounts for 75% of the world's volcanic population. Right? Right. Now, my dear friends, see a continuous region. Okay, now see, I have just given all very important facts about, say, for example, this ring of fire, right? Very important facts. So we're searching how many words we have. Okay, fine. Okay, whatever it is the case, right? Now, see, if the same question is asked for 250 words, somewhere you can give more facts about it. Somewhere you can say, for example, what are the different plates that converge with each other to form the continuous zone of this, right? Continuous or the single longest continuous subduction zone of the world. Okay, right. Few more informations also I have just added it. The ring of fire isn't quite a circular ring. Every time you call them as a ring of fire, but only point what I'm just trying to say, it is actually, it is not, doesn't look like a ring, but rather it almost resembles like an horseshoe, right? That's what somewhere I just diagrammatically represented here also. Though I call it as a ring of fire, it approximately takes the shape of this horseshoe shape. Okay, right. See, diagram, if you ask me, should I draw world diagrams, right? World map diagram or world map? Should I mark these places? Generally, I say not needed. But still, I believe that if you can draw map of India, if at all, if it is needed, for example, assume that they are asking a question, right, in the Indian context. If somewhere, if you feel that, say, for example, somewhere, right, presenting the map of India makes more meaning or adds more meaning to my answer, I would always advocate that you should go for it. But kindly remember, you should somewhere, if at all, if you're attempting to draw a map of India, kindly ensure that that map looks like map of India, right? Practice it. Nothing wrong in practicing the outline map of India. See, not every nuances you have to take it into consideration. Not necessarily, right? All they say, for example, the contours. All they say, for example, the lines, the curves, right? Everything is not right necessary, but somewhere it should be very appealing. Somewhere, my dear friends, I am pretty confident that if you can present, if you can draw map of India, right, in a very pleasing manner, I feel that, say, for example, any person who's correcting your paper will normally, say, for example, or you'll be having an edge over others. As simple as this. Right? We'll see. Right, my friends. Right, as I was saying, the ring of fire isn't quite a circular ring, as I already said. It resembles more like a horseshoe. Right, a convergent boundary is formed by tectonic plate crashing into each other. Right, somewhere if you want to take the name of these plates, right, you are most welcome to take the name of these plates. Okay, it forms subduction zone where heavier plate slips under the lighter plate. To be very precise, oceanic crust will be subducting below the continental crust to form what? Deep trenches. The subduction changes the dense mantle material into buoyant magma, which rises through the crust of Earth's surface. That is what, when the magma starts rising, that process you call them as what? Volcanic activity. Okay. Right, my dear friends. Now, somewhere, few examples also I'm just bringing in. Most of the volcanoes on the Ring of Fire are found in the western side, that is the Asia and the means almost the Asian side, the Pacific regions of Asia and Oceania side. This is a place where you find a lot many number of volcanoes. Okay, almost starting from Kamchatka Peninsula. Kamchatka Peninsula is a peninsula in Russia, right, very near to Kuril Islands, through the islands of Japan, Southeast Asia to New Zealand. To New Zealand. Okay. So somewhere the western side of Pacific Ocean is known for more number of volcanoes. Okay. And that too, you have more of active volcanoes. And a specific example of Krakatoa also I have just taken it. Because when I talk about Krakatoa, why I have just taken Krakatoa? Krakatoa almost belongs to a type of volcano. We call them as what? Pelian type of volcano. Very intense type, explosive type. And the explosion, what is created by Krakatoa? Krakatoa is blasted. So any explosion will create a sound. And the sound that was created by this Krakatoa incident or the blast was so loud that this sound has circumnavigated the entire Earth. Not once, not twice. It has circumnavigated the entire Earth 4 times. Recorded history says Krakatoa blast, the sound produced by the Krakatoa blast is the loudest ever sound that was heard by humans. We have not recorded any sound which is more louder, intense than Krakatoa blast. Okay. So way back in 1883, almost 140 years before it, right, erupted. So somewhere I'm just putting a point that is very much part of what? Pacific Ring of Fire. Right. Mount Fuji, right? Mount Fuji. Somewhere I understand, say for example, Fuji is again a very prominent volcano, what you can have it. Okay, right, somewhere. The examples I'm just adding it. See here, here I have the word limits. If you count it somewhere, I have just taken a word limit which till 400 words, 500 words also I have just taken it. Obviously, everything we are not going to replicate in the examination. Okay, all right, my dear friends. Now some of the volcanoes on the eastern half also somewhere, right, we have just taken for examples, right? The American side, right? Starting from the Aleutian Islands, the Cascade Mountains in the western US, right? The Trans-Mexico Volcanic Belt and Andes Mountains. Andes Mountains also you have plenty of volcanoes, right? Volcanoes like, say for example, you have this Cotopaxi, Mount Chimborazo, Ojas del Salado, plenty, right? Rocky Mountain, if I just take it, you have St. Helens, Barker, Rainier, plenty of mountains we have. Okay. So my dear friends, just giving a gist of what we have seen. If examiner is plainly asking you, what do you understand by Pacific Ring of Fire? You can simply say, the periphery of the Pacific Ocean is very popularly called as Pacific Ring of Fire. It is known for the presence of large number of volcanoes. Not only volcano, right? It is also prone to earthquake. It is also known for the deep sea trenches. And one more thing, wherever I have deep sea trenches, it is also prone to tsunamis. Tsunamis. And the periphery also is known for the occurrence or the presence of young fault mountains, right? And only thing is that I am just giving you some of the facts, right? Even some more facts also I can take. When I talk about the entire periphery of this Pacific Ocean, it somewhere, right, has a perimeter of about 40,000 kilometers of continuous subduction zone. And numbers also I have just given, somewhere around 452 active and dormant volcanoes are there. Nearly 90% of the world's large earthquakes are confined to this region. 75% of all volcanic population of the world is confined to this region. Okay. And somewhere I also told you this is the single largest continuous destructive zones of the world. So if at all, if you can write, say for example, about the plates which converge with them, maybe somewhere I can add more points to it if it is needed. For example, largely it is Pacific plate. Largely it is Pacific plate. Okay. The only thing is that when I talk about, say for example, the eastern side, the southeastern side, adjoining to American side, we have this Nazca plate, right? We have this Nazca plate. Rest all I can write it. One side you have Eurasian plate. Another side I have this Indo-Australian plate, Australian plate. Right. Another side I have this North American plate, North American plate. Another side what I have is South American plate. Okay, so largely it is Pacific plate, but all side it is surrounded by Eurasian plate on one side, North American plate, South American plate, and Indo-Australian plate on one side. Again, I have also brought in one small minor plate. Among the minor plate, Nazca plate is a major plate. Okay, right. So this is all about Pacific Ring of Fire, my dear friends. Okay. Now moving on further. Moving on further. What do you understand by induced seismicity? Second question. What do you understand by induced seismicity? Give some examples. Right. Give some examples. Right. So only things that according to the demand of the question. See, for example, the first question, structure is completely your right. Somewhere your choice. Completely it is your choice. Because the question is very straightforward, direct. Whatever the structure you want to write it, you can write it. Only thing is that every time I have to primarily focus on what? Volcanoes. Because the topic talks about ring of fire. Okay. Here, only thing is that they are dividing this question into two segments. Number one, what do you understand by induced seismicity is first part of the question. Give some examples, right? It is second part of the question. See, very practically speaking, when talk about what do you understand by induced seismicity, even if the examiner would have not asked you this, give some example. Definitely speaking, we are going to give right some of the types and we are going to give some of the examples. Okay, but here since the examiner says that give some example, we have to be more specific on that example. Right, example in the sense not the type, specific example. Right, not just say for example dam induced or reservoir induced earthquake. I have to be very specific on saying that yes, Koina Nagar earthquake, something like that, very specific, right? Now here, practically speaking, what do you understand by induced seismicity? Hardly, right? Very practically, we can define it, right? And somewhere we can talk about the causative factor, causative factor. And somewhere here, while writing an answer, the part one of the question and part two of the question, I can start answering, say for example, simultaneously. For example, if I talk about different types of induced seismicity, right? Every type of induced seismicity, what I am just taking it, I can give one example or two examples there itself, right? Say for example, somewhere, assume that I am talking about one dam induced earthquake. There I can give an example there itself. When I talk about, say, for example, one mining induced earthquake, I can give the example there itself. Over extraction of groundwater, there itself I can give an example. Okay. Now, as I said, first we'll try to define, right? It is always GS if you ask me. I would always say that, say, for example, if at all, if any concept is asked, always the best part of the so-called intro is the definition itself. Okay. Somewhere you're telling the examiner, yes, I know the concept. Okay. Now, what is this induced seismicity? Induced seismicity refers to typically minor earthquakes and tremor that are caused by human activities that alter the stress and strain on the Earth's crust. So everything we have talked about. What exactly is induced seismicity? What is the causative factor? Everything we talked about. Right? It is also called as anthropogenic earthquake or man-made earthquake. Anthropogenic or man-made earthquake. Okay, it is either called as anthropogenic earthquake or it is called as what? Man-made earthquakes. Okay, right, my dear friends. Now, induced in the sense Whenever human activity induces some stress on Earth's crust, that activity may result in an earthquake. If such earthquake is resulted due to human activities, we call them as what? Induced seismicity. That's the reason. The other name itself, we call them as what? Man-made earthquake or anthropogenic earthquake. But see, this is the definition given in popular net sources. This is the definition given in popular books also. But let me slightly tell you the practicality. Not necessarily always these earthquakes are minor earthquakes. No, not necessarily. Because we talk about some of the devastating earthquake. India itself witnessed two devastating earthquakes. One way back in 1967 and one in 1993. 1967, it was there in a place called as Koina. 1993, a place called as Latur. Both the places, the life lost, right? The life loss was very high. Somewhere, say, for example, if you just ask me, the intensity of an earthquake, magnitude was very high. Magnitude was also high. Intensity was also high, right? Somewhere, if that is the case, damage is very high. If intensity or magnitude is very high, definitely speaking, I cannot call it as a minor earthquake. But these are exceptions. Very rarely, such large earthquakes can be caused by what? Human activities. Normally, this dam result, the construction of dams, right? That will be resulting in what's some of the large earthquakes as such. Otherwise, barring that dam-induced earthquake, rest of it you take it, generally you'll be finding these are minor earthquakes. Okay, right, my friends. Now, coming back, there are many ways in which induced seismicity can be seen to occur. Right, as I said, right. See, net sources has given more than 700 different ways how exactly that earthquake, right? Say, for example, man-made earthquakes can be resulted. See, there are bizarre incidents also. Somewhere bizarre incidents are there. For example, I do not know how many of you know this news, right? Way back in 2018, the time 2018 Football World Cup happened in Russia. Russia. So the very first match, it was a match between Mexico and Germany. Germany was the defending champion. 2014, they were the champion. Mexico was a very small country when you see the stardom of German players. The very first match, what happened? Mexico won the match. Mexico was almost having that underdog status, but Mexico won the match. When Mexico won the match, the Mexicans, the Mexican fans who were seeing this match live, once the result was declared, that out of excitement, they started jumping into the air, right? Almost. See, it is emotional, it is instantaneous, it is somewhere, right? What do you call them? Somewhere, right? It is spontaneous, something like that. So everybody started jumping into the celebration. I'm just talking about the celebration. And all this, say, for example, celebrating individuals landed in the ground together, that landing has caused one earthquake. It means that incident has been recorded as a man-made earthquake, right? Somewhere that has triggered that seismograms, the local seismograms as such. So what I'm just trying to say, the number of ways that man-made earthquakes can be resulted, plenty of examples or plenty of types we have. Net sources has identified more than 700 different ways that how man activity or human activity can create what? An earthquake. But not necessarily I'll be talking about such a large number of lists. But what is more common, what is more popular, that I have to revolve around. Right. Right, but if it's in that way, in the past several years, some energy technologies that injected or extract fluid from the earth, such as oil, gas extraction, and geothermal development, has been found or suspected to cause seismic events. Right. Some energy technologies also produce waste that may be managed through disposal or storage by injecting deep into the ground. For example, wastewater from oil, gas production. Okay, we'll see it in detail. Okay, somewhere we'll see it in detail. For example, wastewater from oil and gas production and carbon dioxide from the variety of industrial process may be managed through the underground injection. Okay, I'll just come one by one. See, to make it very simple, even for preliminary examination also I say, mains examination, whatever you know you can write. But one thing is it, wherever there is a large scale tampering of lithosphere, whether there is an addition of weight or removal of weight, both can result in an earthquake. Some of them has caused in the past, some of them will be causing the same in the future. Okay. I'll go only by the past examples because examiner is asking you the examples. Okay. Right. Artificial lakes. Either you call them as artificial lakes, right? Or you call them as what, say, for example, reservoirs. I'll call it as a reservoirs, right? Reservoirs, right? Reservoirs. Or let me call it as dams. See, this is artificial lake, just not lake. It is artificial lake, man-made lakes, right? So artificial lakes, reservoirs, dams. These are some of the ways how exactly, right, earthquakes are caused. And let me tell you, my difference. Earthquake caused by this artificial lakes generally happens to be large earthquakes, right? Already I have just given you one example, Indian example I have just given you, right? So only thing is that I'm explaining here. The column of water in a large and deep artificial lake alters in situ stress along an existing fault or fracture. In situ means in that place itself, right? The entire, say for example, the entire volume of the water will be acting on the rock below. If at all already if you have an existing fault, right, further stress it will be inducing in that fault, right? In these reservoirs, the weight of the water column can significantly change the stress of an underlying fault or fracture by increasing the total stress through direct loading, right? Or decreasing the effective stress through the increased pore, right, water pressure. Or make it very simple, right? I have huge volume of water acting on the subsurface rocks. Or say for example, the rocks at the bottom of this reservoirs or lakes, right? So somewhere I'm just explaining this process. The significant change in the stress can lead to a sudden movement along the fault or fracture zone, resulting in an earthquake. There can be a slip off. There can be a further fault. Am I right? There can be a further fracturing. Somewhere the rocks can break. Right? That's what we say. Right. Global example also I have just given it, but more than everything, right? Indian example is very important. 1967 Koina Nagar earthquake, Maharashtra. Koina Nagar is Western Maharashtra. Right. One more earthquake example also I should give you. What is that example if you ask me, right? Except Koina Nagar. 1993, Latur. Latur was more devastating. Nearly Latur, somewhere we have lost 10,000 valuable lives. We lost in what? Latur. 10,000 valuable life. Right? Latur. Right, my difference. Now, dam induced earthquake. Indian example itself, I have just given you two examples, right? Even Hoover Dam accident also you can take it as a global example, right? Mining. See, mining is the one which has created large number of earthquakes, right? Artificial lake has created large earthquakes, and mining is the one which has created what? Large number of earthquakes. Among all induced seismicity, all man-made earthquakes, if you take it, which has caused, which activity of human being has caused more earthquake? That is mining, right? So mining leaves a void that generally alters the balance of forces in the rock, many times causing rock burst. These voids may collapse, producing seismic waves, and in some cases, reactive existing faults causing minor earthquakes. Natural, I'd say, for example, almost the cave collapse forming sinkholes would produce an essentially identical local seismic event. Very simple. Mines can create a void. The roof of these mines or the wall of the mine can collapse. If it is collapsing, it may create what? Seismic waves. Wherever mines are very active, even say for example places like Kolar gold fields, even say for example, right, almost in and around the mines of Jharkhand, Odisha, and Chhattisgarh, more number of tremors the local people will be feeling, right? Because I understand mining is the one which has created the large number of earthquakes. Normally, small earthquakes, like more of tremors. Okay. Apart from mining, my difference, it is waste disposal wells. Waste disposal wells. See, for example, what is this waste disposal well? Normally, say for example, even atomic waste for that case, right? We have a deep wells where exactly, right? We normally say, for example, right, very deep holes will be disposing this used fuels as such, like that. Injecting liquids into waste disposal wells most commonly in disposing of produced water from oil and natural gas wells, has been known to cause earthquakes. The high saline water is usually pumped into the saltwater disposal wells, resulting in subsurface pore pressure can trigger a movement along the fault. Okay. Rocky Mountain, say for example, one of the first known example, right? Rocky Mountain Arsenal, way back in 1961, where the wastewater was injected into the deep strata, and this was later found to have caused a series of earthquakes, right? And to be very precise, right, even Spain, I have just given this example, right? Castor project. I'll just come to this Castor project, right? A hydrocarbon extraction and storage. See, large scale fossil fuel extraction can generate earthquake. Induced seismicity can also be related to underground gas storage operation. Castor project. Say, for example, 2013, September, October, right? Somewhere, Spain. What happened? Say, for example, they had a underground cavity, right? Underground cavity. This is the place where they started storing the gas. Somewhere they thought, instead of storing the gas, somewhere, right, in the silos or the tankers as such, they started storing in the subsurface cavity, right? That's what this project is very popularly called as Castor project. And this Castor project, underground gas storage operation, right? It was immediately discarded because it has created so many earthquakes, right? In September 2013, after injection of, say for example, injection operation started, the Spanish seismic networks recorded a sudden increase of seismicity, right? Somewhere they say more than 1,000 events with magnitude anywhere between 0.7 and 4.3, right? That's the largest, right? Almost it was recorded in just about 40 days, right? See, 1,000 earthquakes in just 40 days. Somewhere, this kind of having a large number of earthquakes, technically we call them as what? Earthquake swamps. Earthquake swamps. This earthquake swamps is also associated with volcanic activity. When one dormant volcano starts becoming an active volcano, it normally results in this earthquake swamps. So what is earthquake swamps? When large number of earthquakes, something like this, when large number of earthquakes start striking a small area, right? Small area, right? Located close, something like that, right? Small area in very short span of time. You call them as what? Earthquake swamps. Okay, right. Castor project, specific example. And groundwater extraction, my dear friends. Again, say for example, Lorca earthquake, 2011, Spain witnessed one earthquake, right? Epicenter Lorca in Spain. Again, if you ask me what is the reason for it, causative element for it, the causative reason is over extraction of groundwater. Right, the changes in the crustal stress pattern caused by large scale extraction of groundwater, right, has been shown to trigger earthquakes. See, for example, why Spain? Lorca is a place in Spain. Why Spain? Generally, people depend more on groundwater, if you ask me, because Spain belongs to a type of climate called as Mediterranean type of climate, right? And talk about, say, for example, Spain. As I said, Spain belongs to Mediterranean type of climate. This Mediterranean type of climate, my dear friends, is known for a very unique feature. Generally, any place on earth you take it, normally, we do have an exception, which is normal I'm talking about. Summers will be wet and winters will be dry. India, also I understand, say for example, actually technically speaking, July is summer. Any weather map and all you take it, they'll be having only, say for example, the two extreme seasons, if you ask me, you'll be having a map of July, you'll be having a map of January. January is peak winters, July is peak summers. But now comes the question, right? You may wonder, what is this? My summer is not looking like summer. Summer is not about temperature always. Summer is all about the length of the day. Longer days, right? June 21st, longest day, correct? In Northern Hemisphere. So what I want to tell you, now when I talk about June, July and all, it is known for monsoon. So normally summers will be wet and winters will be dry. Even our own winter, the winter itself is called as dry winter. But Spain, it is exactly opposite. Summers will be dry and winters will be wet. When water is not needed, Water will be everywhere. When water is needed, you'll not find. Summers. Spain is one very important location experiencing Mediterranean type of climate. So Spain's dependence on groundwater will be more. That too, particularly during summers, right? Because surface water will be very, very less availability. So their dependence on groundwater will be very, very high. Okay, right, my dear friends. Now, somewhere I have just given you one example. Then comes geothermal energy. See, for example, particularly when I talk about enhanced geothermal systems. See, normally when I talk about geothermal energy, you'll be using this geysers and hot spring sources, right? When I talk about enhanced geothermal systems, where you'll be somewhere pumping the fluids, right? Somewhere, almost say for example, in the subsurface. And if at all, say for example, almost, because I understand, as you increase the depth, normally what happens, you call them as geothermal gradient. The temperature of the earth will increase, right? The temperature, right? Temperature will increase in Earth's interior. Normally, say for example, lithosphere every 32 meters you descend, 1 degree centigrade will increase. So somewhere geothermal energy, particularly when I talk about enhanced geothermal energy, you'll be pumping fluids into the subsurface system, right? That may also say for example release some heat, and using the heat, if at all, if you're utilizing the heat for energy resources, you call it as same, right? This enhanced geothermal system also has a higher potential to somewhere result in induced seismicity, hydraulic fracking or hydraulic fracturing, you can call it as, right? It is one of the method used for shale gas extraction, right? Again, say for example, it has one of the huge potential to cause what? Earthquake. The two, magnitude more than 4 means feelable, right? Some amount of destruction will be there, right? Even carbon capturing and storage has created some of the volcanoes, right? Ohio volcanoes, right? Nuclear activity. Even Pokhran test, my dear friends. Pokhran test, Indian example itself, when I talk about Pokhran test, when it completely, this operation Pokhran was completely a stealth operation, right? Hardly the world knows that India was developing one nuclear capacity. When we have done this test, almost say, for example, this particular event was recorded as an earthquake globally, right? Only we ourselves said, no, that is not an earthquake. We have tested our nuclear facility or nuclear, right? Almost weapons we have tested. Okay. So what I just want to tell you, not only nuclear activity, any weapon of mass destruction, if at all, if it is tested, right? Somewhere that will be producing some seismic waves. Particularly, it will be producing that surface waves. And that surface waves will be somewhere recorded in the seismograms around it. Okay. See, I have just given you some specific examples, right? Explaining those specific examples is not needed. Explaining, right, how exactly it is going to induce and all, it is not needed. You can talk about the type, you can give the examples. Okay. If at all, if the same question is asked for 250 words, I would say that you can give more number of types and more examples instead of explaining each and everything. Okay. Right, my dear friends. So, two questions we have done with. Now, I am just moving on to the third question. I have just taken the clue from, right, yesterday and today. Series of cloud burst we experienced, right? Repeated landslides in Uttarakhand, Himachal Pradesh, right? Repeated. And this time, see, for example, it's very surprising. Of course, we're just waiting for more studies to come. What is very surprising in the sense, right now we are experiencing El Nino condition. Right now, normally during El Nino condition, our monsoon will be weakened, right? It will be weak. But somewhere surprisingly, we are having a very strong monsoon. Even say, for example, again the flood alerts are given. Again, the heavy precipitation alerts are given, right? Particularly, say, for example, Delhi has registered, right? Almost say, for example, one of the highest single day precipitation, right, in the past few decades. Chandigarh has recorded the highest single day precipitation, if I'm not wrong, right? Uttarakhand has recorded one cloud burst, right? Very recently. If I'm not wrong, say for example, almost very recently. Kulu has experienced one cloud burst, again less than a day, right? The only thing is that somewhere we are just talking about this cloud burst. What is cloud burst and how does it differ from? Okay. What is cloudburst and how does it differ from normal rainfall? Also analyze the reason for frequent occurrence of cloudburst in India in the recent years. See, first and foremost, divide the question. First, explicitly two questions are given, right? Question number one, they say, what is cloudburst and how does it differ from normal rainfall? Number two, also analyze the reason for the frequent occurrence of cloudburst in India in recent years. Okay, two questions are there. First question, I have to talk about cloudburst, and somewhere I have to talk about the difference, how it is different from normal rainfall. Second, I have to talk about the frequent occurrence of cloudburst in India. What is the reason? And within first question, they're asking you what is cloudburst is one, and number two, you have to differentiate this cloudburst from normal rainfall. Okay. So, what is that I have to write it approximately? I have an idea. I have to define it. I have to see what exactly, how exactly it is differ from the normal rainfall. Heavy rainfall also I can take it. Then, of course, the second part I have to write the reasons for the occurrence of the cloudburst. See, always one reason is universal. Okay, we'll talk about it. Now, what is a cloudburst? See, let me tell you, my dear friends. We do not have any standard definition saying that what exactly is a cloudburst. Okay, but somewhere, right, we started using even IMD somewhere, right? It started using that if at all, if a very small area, say somewhere around 20 to 30 square kilometer of an area, if it receives more than 100 millimeters or more than 10 centimeters of precipitation in less than 1 hour, that situation we call them as what? Cloudburst. As a layman, if you want to understand, I can say very heavy, one more very also you can add it, very heavy precipitation. Heavy precipitation, you call them as what? Cloudburst. Okay, I'll define it. Right, most of the documents in IMD, how exactly we find it, somewhere I'll just put it. Right, cloudburst or sudden and extreme rainfall events, very important, over a limited area in a short span of time. In a short span of time. Three components are there. See, extreme rainfall is one component. Limited area is second component. Short span of time is third component. Okay. Now, all three I am going to say, for example, somewhere I am going to define it. Right. Now, for example, cloudburst or sudden and extreme rainfall event. How extreme? More than 10 centimeter of precipitation over a limited area, somewhere around 20 to 30 square kilometer of an area in a short span of time, that is in less than 1 hour. That's what the definition is. Okay. And again, I'm saying there is no universal definition of a cloudburst. However, the Indian Meteorological Department defines a cloudburst as an event where 100 millimeters, 100 millimeters or 10 centimeters, both are same, have fallen in a span of an hour, right? Small span of time, right? Over a region that is 20 to 30 square kilometer of an area, limited area. Okay, all components we are taking it. Okay, right. So what is cloudburst? We have an idea. Okay. Right, my dear friends. Now, somewhere, right? Rain is condensed water falling from the cloud, while cloudburst is sudden, heavy rainstorm. Somewhere we are differentiating between the normal rain and cloudburst. What is a rain? Rain is a simple form of precipitation where it is falling from the cloud, right? Whereas cloudburst is sudden and heavy rainstorm. It is more like a rainstorm, right? Now, my dear friends, and one more thing. A report in Down to Earth said a cloudburst is different from rain only in the amount of rainfall recorded. Mechanism and all more or less same, right? Why more or less same? It is same. That is also precipitation. This is also precipitation. This is also rainfall. This is also rainfall. But only thing is that I am using this word called as heavy, right? So somewhere the difference comes in only in matter of the amount of precipitation, not in any mechanism. But The type of cloud may also differ. That also I've just brought in. For example, this normally my difference. When I talk about this rainfall can be resulted by any type of cloud. Any type of cloud. It can be, say, for example, cumulus cloud, right? It can be somewhere by stratus cloud, right? Cirrus cloud, hardly it results in any precipitation, right? Either it can be cumulus cloud or it can be what? Stratus cloud. Cumulus or it can be stratus. When talk about, say, for example, this cloud burst is caused only by nimbus cloud. Now you may wonder, what is this? I have a cloud called as cumulonimbus cloud. That's a combination, but it is nimbus, right? Cumulus cloud alone cannot result in cloud burst. Only cumulonimbus cloud can result. Stratus cloud alone cannot result in, say, for example, cloud burst. It should be nimbostratus cloud. Okay. So that is one more difference what you can bring in. Okay. So cloud burst is resulted only by what? Nimbus cloud. Nimbus clouds are bad weather cloud. Okay. Right, my difference. Further getting it. Rain over 100 millimeter per hour is categorized as cloud burst. Repeated points, right? Examination, you don't repeat it. Okay. Hence, we can say that cloud burst is a natural phenomena, but occurs quite unexpectedly, very abruptly, and rather drenching, like something like a waterfalls it will be falling, right? In Indian subcontinent, it is generally occurs when a monsoon clouds drift northwards from Bay of Bengal or Arabian Sea, crosses the plains onto the Himalayas, sometimes brings somewhere 75 millimeter rain per hour, right? This point also you can leave it, not needed. Okay, so the first point, we have defined what exactly is a cloud burst, very, very important. And what is the difference between this cloud burst and normal rainfall? That also we have differentiated two difference. And talk about difference as such, actually speaking, there is no much difference. Okay. Only amount of rainfall makes the difference, number one. Number two, normal rainfall can be resulted by, say, for example, any type of cloud. Any cloud. Any cloud, including nimbus cloud. Not necessarily that every time nimbus clouds will be resulting in cloud burst, whereas cloud burst can be resulted only by nimbus clouds. And talk about nimbus cloud, either it can be cumulonimbus or it can be nimbostratus, both. Very dark cloud, very dark cloud. Why it is so dark? Because this cloud is so thick, it will not allow the sun's rays to penetrate. Okay. Now, my dear friends, somewhere I'm just answering the second part of the question. Also analyze the reason for frequent occurrence of cloudburst in India in the recent years. Right? Recent years. Okay. Now somewhere I'm just talking about this reason for cloudburst. See, a cloudburst occurs when moist or moisture carrying air moves up a hilly terrain, forming a vertical column of cloud called as cumulonimbus cloud. Okay. Such clouds usually cause rain, thunder, lightning. This upward motion of the cloud is known as orographic lift, right? These unstable cloud cause an intense rainstorm over a small area after becoming heavy enough and locked in the ridges and valleys between the hills, right? What exactly this paragraph says, I'll tell you, right? What is the reason, right? Or how? Normally, right? Whenever, simple, whenever the rate of rise of this air mass, already, say for example, already this air mass will be carrying a lot of moisture. Along with it, if at all, if the rate of rise of this air mass is very strong, right, very strong, the rate of condensation will also be what? Very, very strong. And within the cloud, the vertical movement within the cloud, what we call them as updraft and downdraft, will also be what? Very, very strong. So normally what happens is monsoon wind already it will carry more of moisture, right? So as and when, right, it starts ascending the steeper side of the mountain. And that too, I know the fact, the southern slopes of Himalayas are very steep, right? So when the rate of rise of this air mass, right, if it is very, very strong, right, more chance it will be resulting in what? This cumulonimbus clouds, right? So only thing is that if the rate of rise of air mass is very, very strong, right, either by orographic lift or by the convectional process, both can result in cloud burst. Okay. So here monsoon already carries more of a moisture, right? And that to see my difference. What happens? Because particularly right? Why exactly Himachal Pradesh and Uttarakhand experience more of a cloudburst, if you ask me. The same wind, when it surpasses Rajasthan do not have that orographic barrier. Aravali fails to act as that orographic barrier. So largely this moisture-laden wind will be surpassing Rajasthan. Very little precipitation, it will be somewhere resulting, yielding in Rajasthan, or somewhere it will be resulting. This wind will be carrying more of moisture, and finally it reaches the foothills of the Himalayas. All of a sudden, once it starts encountering Himalayas, it will start rising. The rate of rise will be very, very strong, right? That's the one, it results in the formation of what? Cloud burst, right? Sorry, excuse me. It results in the formation of what? Cumulonimbus cloud, which is known for cloud burst. Okay. The energy necessary for the cloud burst comes from the upward motion of the air, right? Well, that's what I was said. Cloud bursts mostly occur at an elevation between, right, 1000 to 2500 meters above the sea level. The moisture usually provided by low pressure system. See, too technical, though I have written it here, somewhere in the examination you can avoid it, right? Sometimes winds flowing in from northwest also aids the occurrence of a cloud burst, right? The many factors that have come together in making a cloud burst event happen make them highly unlikely. Okay, and one more thing, I'll tell you, whenever any weather phenomena, which normally, say for example, which is abnormal, right? Which is abnormal. Now it starts becoming normal, right? For example, El Nino occurrence is very rare, but nowadays, once in 2.5 years, 3 years, we start experiencing this El Nino, right? Okay, at least 2018 we had a last El Nino, and 2023 we had another El Nino, somewhere after a gap of 5 years. Okay, whatever it is the case. Now, the abnormal weather phenomena are becoming what? Very, very common. Any such question, if it is asked, always you can have one of the causative factor as what? Global warming. See, global warming is an universal answer or universal question. And I can also talk about, apart from global warming, yes, instead of calling it as global warming, I can call them as what? Climate change. Global warming talks only about one dimension of temperature increasing. Climate change is multi-dimensional. It talks about, say, for example, grim winters versus harsh summers. Both it includes. Okay. So always you can take the name of climate change, global warming. Am I right? Um, Say, for example, the anthropogenic modifications of human beings, right? Increased level of greenhouse gases, right? Increased level of greenhouse gases. Now you may wonder, what is this? If global warming is there, how come heavy precipitation? Very simple. See, cloudburst particularly, whenever the rate of rise of air mass is very, very high, right? Vertical rise is very high, it may result in cumulonimbus clouds. And normally I understand even the temperature, if it is very high, the rate of rise will be very high. Correct. So somewhere, right? If the temperature, very high temperature will also bring what? Precipitation. Will also bring what? Cloudburst as such. Right? Right, my dear friends. Now, both the answers or both the questions we have answered. See, how to counter cloudburst, I have just given it for the simple reason, right? It is not part of your answer. But if at all, if a question is asked in 250 words, right? Somewhere after talking about the causative factor and the general difference between cloudburst and the normal rainfall. If you have time and somewhere if you feel like writing it, somewhere I can write it. How to counter the, see, it is not how to counter cloudburst. I should talk about how to counter the effects of cloudburst, something like that. So always early warning system, right? Detecting cloudburst is difficult task as it covers a small area, right? So precautions will go a long way in lessening the damage, right? So what all I can do? Stopping hazardous construction in hilly area, because the cloudburst itself is not hazardous. Cloudburst induced flash flood is hazardous. Cloudburst induced landslide is hazardous. Okay. And that too, I understand cloudburst normally occurs in hilly region, right? Because they say, right? Normally, right? Cloudburst mostly occurs at the elevation between 1000 to 2500 meters above sea level. Okay. If that is the case, somewhere I understand already it is a hilly region, already it should be a plateau region, right? Somewhere steep slopes has to be there. So somewhere we are minimizing and stop hazardous, haphazard construction in hilly areas, preventing encroachment in the riverbed because we should somewhere provide that easy access or flow of these rivers. Okay. Afforestation program, especially on hill slopes, because afforestation, any forest trees will be having deep roots. Deep roots will be holding the soil together. Okay. Alert relay system, that is early warning system, if at all, if it is possible, you can put in place. The damaged ground must be replanted as soon. Okay, this and all just to add it. Right? Doppler weather radar are ideal for near real-time tracking of potential cloudburst. Okay, right. So these are some of the right ways how exactly we can put ourselves in a place of safety even if we have this cloudburst. Okay, this part is a junk, not part of the question what is asked. But somewhere I am just saying if you have time in the real-time examination, somewhere you can go for it. Okay, right, my dear friends. Okay, question number 4. What do you mean by energy security? How far exclusive economic zone can augment the energy security of a nation? Augment is more like increasing. Okay. Now see, two questions. Number one, what do you mean by energy security? So I have to describe what is energy security is part one of the question. How far EEZs can augment the energy security of a nation? If that is the case, first and foremost, I have to tell the examiner that what do I mean by EEZ? Correct. I have to tell them that at least I know the abbreviation of EEZ. And what is this EEZ? I know. That adds to the credibility of the answer. Then I should say what are the energy that is available in the EEZ and how exactly this energy, right, somewhere available in the EEZ can augment, right, to the existing energy, almost say for example, almost the potential energy reserves of a country, right? Somewhere we'll start connecting it. Approximately you can almost say for example, okay, right, my friends. If that is the case, very practically speaking, what do you mean by energy security? Will say for example require only say for example minimum number of words, and how far easy can augment the energy security of a nation can include more words, right? Less words versus more words. Okay, I'm not even telling you how many words, but less versus more. So first, let me define this energy security. And one more thing, see, for example, normally what happens? Examiner has explicitly given you two questions, question number 1 and question number 2. If you just define what is energy security in one single sentence, and if you start writing how far easy can augment the energy security of a nation, somewhere my mark distribution may not be justified. Okay. Try to enhance it. See, obviously, I know that, say, for example, I'm going to write less about energy security and more about, right? The energy security means what are the different sources, energy, what I have in EEC, how it's going to augment the energy security of a nation. I'm going to write more. That is okay, right? But writing one single sentence or small paragraph and going to the second part of the question is not so logical. So kindly we have to elaborate on this energy security. That's what I've just done it here. Okay. So first I'm defining it. It's always better, general studies I said, right? Better you start the answer with a definition. Okay. In that way, my dear friends, what do you mean by energy security? Right? And talk about, say, for example, almost IEA defines energy security as the uninterrupted availability of energy sources at an affordable price. See the words. Number one, the uninterrupted, it means continuously I should have the source of energy. Availability of energy sources, that too at an affordable price. Right? not at a premium price, at an affordable price. See how exactly beautifully the sentence is drafted. See, that's the reason normally we say, if somebody is asking you, what is the definition of a definition? Normally we say define. If you ask me, what is the definition of a definition? Trying to somewhere give the complete picture of a concept using the minimum possible words. I call it as a definition. Okay. Somewhere UPSC answer writing should be more like this. I have to use minimum number of words, right? But somewhere I have to, for example, maximize the content part of it, right? Minimum words, maximum content, right? That is the most important way of writing an answer. Okay. Now I am adding, say, for example, I have defined it. Apart from defining my difference, now I'm just giving you the different dimensions of what this energy security. What are the different dimensions of energy security? For example, in that way, right? Different dimension, as I said. One is long-term security, right? Short-term security. Short-term security. What is this long-term security? I'll tell you. Long-term energy security mainly deals with the timely investment to supply energy in line with economic development and sustainable environmental needs. It means somewhere I am planning the future. That is long term. Somewhere I am anticipating, if at all, if my economic development is growing at this rate, right, to sustain it, tomorrow I will be needing more of energy, right? So somewhere I have to make that energy possible, available to me. Otherwise, the rate at which I grow may not be sustained. Okay, so that is very important. Okay, right. Okay. Number two, it is short-term energy security. Just give me a minute. Okay. Okay. So somewhere I'm just talking about this long-term energy security and short-term energy security. If you ask me what exactly is a short-term energy security, right? As the name itself says, short-term energy security. Right. Security focuses on an ability of energy system to react promptly to sudden change within the supply demand balance. All of a sudden, say for example, somewhere the most important word here, right? One is affordable price, but more than affordable price, it is uninterrupted. Somewhere when it is getting interrupted, right? Whatever the measure we take it to ensure that it is available, you call them as what? Short-term energy security. Okay. Right, my difference. Now, somewhere I've just given you what exactly is energy security. I've given you the different dimensions of energy security. Okay. I'll also tell you the say vitality of it, right? Lack of energy security is thus linked to negative economic and social impact of either physical unavailability of energy or prices that are not competitive or over volatile. See, somewhere that's the reason I said, right? Even if you want to maintain the status quo, right? Forget about the growth. Somewhere, if you feel that, okay, even that economy should not, say, for example, have its negative growth rate, right? Even for that, you need the basic availability of energy. Okay. Right, my dear friends. Now, for the first part of the question, approximately we have answered it. I have added more words because I just don't want to stop it only with this definition of this energy security. Now, I have to answer the second part of the question. How far exclusive economic zone can augment the energy security of a nation? Okay. Support increase, right? Exclusive economic zone. So first and foremost, I have to tell the examiner that what is EEZ, right? EEZ stands for exclusive economic zone, right? So exclusive economic zone is a sea zone prescribed by United Nations Convention on Law of the Sea. Very popularly, we call them as what? UN clause, right? By abbreviation, you call them as what? Right? You call them as what? UN clause. Okay, right. Or which a state means your country. Okay, to be very precise, any littoral countries. What is a littoral country? Any country which has a coastline, you call them as what? Littoral country, right? So, EEZ is a sea zone prescribed by United Nations Convention on Law of the Sea, UN clause, right? Which states that, right, which a state has a special rights regarding the exploration and use of the marine resources, including the energy production from water and wind. Okay, right. So somewhere it is a zone in the ocean. It is a zone in the, say for example, almost in the oceanic region where state largely has a special rights. Okay, normally from the baseline. See, even if you take this baseline as a coastline, nothing wrong. But technically, baseline and coastline are different. Baseline is a smooth line, whereas coastline is not a smooth line. Coastline I'll be having in number of, say, for example, almost the twists and turns. Right? It is not a smooth line, but baseline will be a smooth line, something like this. Okay, that's a different, right? So whatever is the case, from the baseline, normally up to 200 nautical miles, approximately 370 kilometers, right? 370 kilometers approximately, my difference. 370 kilometers. I'll be having a region in the ocean where it extends as an exclusive economic zone. Now I just included one diagram. Not necessary if you want to somewhere, say for example, represent, you can represent it depending upon the word limit. Okay. So where exactly I have this exclusive economic zone of India, peninsular part of India, the 9 littoral states, where all I have this exclusive economic zone. Normally 200 nautical miles, but somewhere I'll be finding this extra exclusive economic zone in Arabian Sea and Bay of Bengal that is contributed by the island territories of Lakshadweep and Andaman and Nicobar Islands. Okay, right. Otherwise, the state, littoral state, which has the least exclusive economic zone is state of Tamil Nadu. Right? And that's the reason, say, for example, Sri Lanka and Tamil Nadu, the fisherman problem is very high. Because, say, for example, the contiguous zone, territorial waters, exclusive economic zone, all three lines will be overlapping here. Right? And there is no buffer zone. There is no concept of international waters between India and Sri Lanka. There is no international waters. Normally, for example, there should be some transition even between the land between two countries. You have something called as no man's land. But unfortunately, between India and Sri Lanka, you do not have any, it's nothing called as no man's water. You do not have anything called as high seas or international sea, right? Somewhere if you're crossing Indian waters, directly it is Sri Lankan waters. Okay. Maybe who knows, in the future, they may bring this concept of international sea between India and Sri Lanka as such. Okay. So otherwise, the accidental crossing of fishermen can be avoided. Okay. Whatever is the case, right? Without deviating much from the topic, we are talking about the energy resources available in the exclusive economic zones. Right? See here, to be very precise, the question do not talks about India. Right? I can talk about any country. But only thing is that instead of talking about some other country, nothing wrong if I just talk about the exclusive economic zone of India. Okay. So here, if I just talk about the different oceanic reserves and their significance, particularly I'm just talking only about the energy reserves of this exclusive economic zone. Number one, the conventional hydrocarbon reserves, right? I'm just talking about, right, the reserves, crude oil, right? Crude oil, crude oil in this region, right? Exploration of offshore petroleum and natural gas. I'm including both petroleum and natural gas because wherever I find crude oil, petroleum, they're all, I also find what? Natural. They are byproduct. But other way it is not possible. Sometimes few places, KG basins for particular, I'll be having natural gas, but I may not have petroleum. I'll put it this way, right? Wherever you have petroleum, I'll have natural gas. Not necessarily that everywhere I have natural gas, I'll be having petroleum. Nothing, right? There are few places where I'll be finding only natural gas also. As I have given, right, something like a KG basin. Okay. Now my difference here. Indian context, Arabian Sea, Bay of Bengal, both I'll be having substantial, right, exclusive economic zone. Particularly when I talk about, say, for example, right, when I talk about places like offshore oil fields of Gujarat, offshore oil fields of Maharashtra in the name of Bombay High and others, right? I understand Arabian Sea has plenty of continental shelf, right? Exclusive economic zone. And when I talk about Persian Gulf, countries which is surrounding, say, for example, the Gulf, right? Persian Gulf, largely you call them as what Gulf countries. So, other than the countries of Persian Gulf, only India produces commercial quantities of oil from offshore areas with a large proportion of its total production coming from the fields of the coast of Mumbai, right? Production wise. I'm not talking about reserve wise, production wise, I'm just talking about. Okay. Conventional. It is conventional hydrocarbons. Petrol also I can talk about, crude oil in general. Natural gas also I can talk about, right? I can also talk about atomic minerals. See, atomic minerals, I cannot take it largely as exclusive economic zone, but the coastal areas. Coastal areas is more known for monazite sand, right? Particularly when I talk about Kerala coast, right? So monazite sand occurs on the east and west coast in some places in Bihar also. Right? Bihar, you don't, let's not consider now because let's concentrate only on the coastal areas and exclusive economic zone. Okay, but whatever it is the case, the largest concentration of monazite sand is on the Kerala coast, right? Somewhere, okay. And it is also believed that over 15,200 tons of uranium is estimated to be contained in what? Monazite sand. Okay. Right, my friends. Now, atomic minerals also somewhere I can take it. As I already talking about the KG Basin. KG Basin is one of the larger area of the gas reserves what we have, right? The researchers from ARI, right? Agarkar Research Institute have found that the methane hydrate deposits are located in Krishna Godavari basins or in, right, biogenic origin. Okay, forget about the biogenic origin, right? From the flora and fauna, it had its origin. Even the lowest estimate of this methane present, right, almost say for example, almost the methane hydrate in kg basin is twice that of all fossil fuel reserves available worldwide. Am I right? I'm not putting in numbers. I am putting in qualitative words. Okay, right. And somewhere they deposit, somewhere they said, right? They say approximately you have somewhere around 7.68 trillion cubic feet of this, say for example, reserve. Researchers have also predicted that the rate of biogenic methane generation in kg basin hydrates to be, right, 0.031, right, millimolars, right, whatever the unit is, resulting in the total deposits of methane around 0.56 to 7.68 trillion cubic feet. Okay. See, data, if I'm not very sure about data, I would say that you go for qualitative words. You can say that very large reserve of gases somewhere is identified along this KG basin. Or if you're very, very precise, I can use words like KG basin. The methane hydrates are twice as that of all fossil fuel reserves available worldwide. Very, very powerful statement. Okay. And apart from that, what else I can write it if you ask me? Obviously, I can talk about, because see, when I talk about exclusive economic zone, already when we talked about exclusive economic zone earlier, right? It says exclusive economic zone. See, special rights regarding the exploration and use of marine resource, including energy production from water and wind. Even somewhere, if you want to, somewhere install windmills there, you can do it. But only thing is in India, coastal areas or within the somewhere the continental shelf, we normally avoid going for windmills for the simple reason both the coast of India is prone to cyclones. That's the reason. It's not just bringing a windmill, but since cyclonic surge is more, somewhere we refrain it from almost say, for example, choosing a coast which is more prone to what cyclones. Okay. What else you can write if you ask me? Obviously, I can write about the tidal energy production. Tidal energy. Right. Again, say, for example, tidal energy, right? I can talk about the east coast versus west coast. Particularly when I talk about Gujarat coast, right? Gulf of Kutch and Gulf of Khambat, right? Gulf of Kutch alone, the Kutch alone, somewhere, it has the somewhere capacity of 7,000 megawatt of potential. And talk about, say, for example, Gulf of Khambat or Gulf of Cambay, Cambay again has somewhere around, say, for example, 1,200 megawatt of what? Somewhere potential. And talk about, say, for example, Sundarbans region, West Bengal coast. West Bengal coast has somewhere around 100 megawatt of potential, right? All with respect to what? Tidal energy potential. I can also talk about OTEC. right? OTEC. Only thing is that I'm confining to energy alone. OTEC means ocean thermal energy conversion. Okay, that can also be what added. Okay, right. These are okay. Some of the, say for example, the sources of energy, what we somewhere get it from the oceanic regions, conventional energy, non-conventional energy, both we can include. When talk about conventional energy, I can talk about, say for example, hydrocarbons, includes both petroleum and natural gases, right? Even say for example, the methane hydrates in KG basins, I can add it. Non-conventional energies like OTECs, tidal energy, everything I can add it. Okay, right. Right, my friends. Now, we have answered that question. Okay. Now, taking one more question. What do you understand by landfall of cyclone? What do you understand by landfall of cyclone? Question, right? First part of the question. Also explain why the east coast of India is more vulnerable to cyclonic surge than west coast of India. Two questions over there. What do you understand by landfall of a cyclone is first part of the question, or first question number one. Also explain why east coast of India is more vulnerable to cyclonic surge than the west coast of India is second part of the question. Okay. Now see, again, logically, if you ask me without any assigning the number of words, I'll say just what you understand the landfall of the cyclone, it's just somewhere I'm just telling you what exactly is landfall. But somewhere if I rationally approach it, I need more words to explain the second part of the question. So I'll just simply say more. Okay, simply say more. Again, the logic, less, don't stop it with one single paragraph. Okay, right. Right, my dear friends. So first, I'll start with what do you understand by this landfall of a cyclone. So every time, right, very recently also we had a Biparjoy. Before that, we had a cyclone called as Mocha. Am I right? Okay. Now, what is this landfall? According to United Nations National Hurricane Center, or forget about it. This also you can avoid it. If you add it, it will give you more credibility. Otherwise, simply you define it. A landfall is the intersection of the center of a tropical cyclone with the coastline. So here I'll make it slightly simple. You ask me what exactly is the center of a tropical cyclone. Center of the tropical cyclone, you call them as what? I. It is the interaction or intersection of the eye of the cyclone with the coastline. Where exactly I'll be having a high, I will be at the center of the cyclone. So, and the eye overlaps with the coastline, I call them as what? Landfall. Simple. In other words, landfall is when the eye of the cyclone moves to the land after being on the water. It means at least only when half of the cyclone enters the land, you call them as what? Landfall. To be very precise, it is not the outer margins of the cyclone entering the land, you call them as landfall. Eye of the cyclone, right? Assume that this is eye of the cyclone. This is the coastline. Eye of the cyclone entering the land, you call them as what? Landfall. Okay. Not the outer margin. Okay. So this does not mean the cyclone has hit the land or arrived. The cyclone arrives hours before the landfall, bringing rainfall and dust storm. See, sometimes what happens? The outer margin of the cyclone will come. Normally, this will be happening in west coast, except Kerala and Gujarat. Gujarat, you can have a landfall. But Maharashtra, Goa, and Karnataka, normally you take it. Landfall is very uncommon. I'm not saying landfall you will not have. It's very rare. But still, you will have the cyclone's effect, right? Slowly, slowly, heavy precipitation, the outer margin of the cyclone will be entering, but somewhere Western Ghats may not allow the further entry of the cyclone within the land. Okay. So as that's what I said, right? Cyclone hitting the land is different. Cyclone somewhere having its landfall is different. Okay. Hitting the land, even if the outer margin of the cyclone, if it starts entering the land, I call them as what? Hitting the land. But only half of the cyclone surpassing entering the land, eye of the cyclone entering the land, you call them as what? Landfall. Okay, right. A landfall often carries heavy winds, lashing rains, increasing sea level, to be very precise, sea surges that can pose threat to people living in the neighboring region. I'm just adding more words. Okay. Hurricanes or cyclone can start losing its energy and speed after hitting the land as they get energy from the ocean water. However, that doesn't happen so quickly. So what I'm just trying to say, once the landfall occurs, right? Diagrammatically also somewhere I'm just showing you. If you want to somewhere replicate this diagram, somewhere you can have a coastline and somewhere you can have the eye of the cyclone and somewhere you can say eye of the cyclone entering the land, coastline, land, and say for example sea. Instead of ocean, I prefer the word called as sea because normally cyclones are confined only to what? Marginal water bodies of the enclosed seas, not in the open ocean. Okay, right. So, eye of the cyclone entering the land. You call them as what? Landfall. Okay. Right, my dear friends. What is a landfall? We have taken it. Now, coming to the second part of the question. Why? Very important, and this is a tricky question. Okay. See, we can go for simple approach. Why east coast of India is more vulnerable to cyclonic surge than that of west coast of India? See, this is one common fact. Normally, if I just take it somewhere, if I start watching the number of cyclones that enters the coast of India, normally you'll be finding that cyclones entering the east coast will be more. Odisha. Every time we'll be finding Odisha is there in news. Andhra Pradesh will be there in news. West Bengal will be there in this news. Tamil Nadu will be there in news. Even among these four states, what I have taken, Odisha is more prone to this cyclonic surge. Right. Okay. Now going by the fact, about 308 cyclones struck the coastline of India, right, from 1980 to 2000, 20 years of time. Okay. While 48 cyclones crossed west coast. Let's see the difference. Out of 308, only 48 crossed west coast. The remaining, say for example, they are east coast. To be very precise, somewhere I should take 260 cyclones, if my mathematics is correct. Okay. 260 cyclones has entered the east coast, whereas only 48 cyclones entered what? West coast. But what is interesting here, it appears as though the ratio is somewhere around 5 to 1. But let me tell you, Arabian Sea versus Bay of Bengal. Arabian Sea versus Bay of Bengal, if I just talk about it, actually speaking, the ratio of cyclone is 1 is to 3. For every one cyclone in Arabian Sea, I will be having 3 cyclones in Bay of Bengal. That is ratio, normal ratio. But somewhere if you ask me, right, the reason is that here the ratio is coming as 1 is to 5 because normally the cyclones, right, which is forming in Arabian Sea, say for example, there is a chance, more chance that they'll be moving towards what? West. It means only if it starts moving towards east, it will be entering what? Indian coast. Because normally, if you ask me, normally, Arabian Sea and Bay of Bengal, both you take it. What is the default movement? They'll be moving towards the poles. They'll be moving towards west. But not every time. Not every time. See, when I talk about the cyclone season in India, this October, November is more prone. Even month of April and May is also prone. But October and November is highly prone to cyclone. And October, November cyclones, this is how they will be moving. They'll be moving towards the poles, they'll be moving towards the west. So, Bay of Bengal cyclone entering the east coast is more, say for example, almost probable than Arabian Sea cyclones entering what? West coast. Okay, whatever it is, one by one, if I'm just taking it. See, for example, whatever I've taken it, I'll consolidate into simple facts. Simple facts, right? Forget about all these words, right? It is taken from the right authentic material, right? They say, for example, surface sea temperature and humidity are directly related to the formation of cyclone. Bay of Bengal receives high rainfall. The possibility of cyclone formation is also high. The winds over Bay of Bengal are said to be a lot more sluggish compared to Arabian Sea. Therefore, the wind fails to reduce the surface temperature of the sea, and therefore the wind fails to reduce the surface temperature of the ocean. Okay. And as I was said, right, the NCR MP data shows that about 58% of cyclones are formed in Bay of Bengal will hit the east coast. See, more than majority, nearly 60% of the Bay of Bengal cyclones are entering what? the Indian coast, whereas only 25% of the cyclone of Arabian Sea are entering what? West coast. You remember how exactly this 1:3 ratio has become 1:5 ratio. Okay, now, as I said, we'll keep it simple. If you ask me, number one, see formation. Why East Coast is more than West Coast? First and foremost, formation, right? Arabian Sea versus Bay of Bengal, right? Bay of Bengal. Already we said the formation of cyclone itself is more in Bay of Bengal. If you ask me why, number one, I would say the average temperature of Bay of Bengal is more. They have given more of fresh water is adding, more rainfall, that and all it is okay. But more than everything, it is more enclosed. It is more enclosed by the land. So average temperature of Bay of Bengal is high, right? Even the temperature is given as 28 degrees centigrade. That is point number one. Because cyclones are generally formed in a place, cyclone is a low pressure. If it is a low pressure, it should be confined to the place where exactly you have more temperature. So average temperature of Bay of Bengal is more than Arabian Sea normally. El Nino, Modoki or somewhere, Modoki kind of a situation that will be different. But otherwise, Bay of Bengal will be more warmer. If it is more warmer, more number of cyclones. Factor number one. Okay. Number two, my dear friends, as I already said, normally, say for example, the cyclones will be moving towards poles, the cyclone will be moving towards west. If that is the case, Bay of Bengal cyclones, my dear friends, already we said, by fact we said, 58% of such cyclones have entered what? East coast. Whereas only 25% of these cyclones have entered what? West coast. Right? Normally, only a cyclone which is having its occurrence during the month of, say for example, April, May in Arabian Sea can enter West Coast. But when exactly I'll be having more of cyclones forming in the month of October and November. Right? Fine. So two things. Right? So Bay of Bengal cyclones entering East Coast is more, say for example, most probable than Arabian Sea cyclone entering what? West Coast. And more than everything, right? I would say, for example, the third example, right? This is very important. Somewhere just now, the earlier part, we talked about the lands, right? The land, sorry, we talked about landfall. We are talking about landfall. What is landfall? Somewhere I said nearly half of the cyclone should enter. Landfall is very common in East Coast because the coastal plains are very extensive, right? I'll call this extensive coastal plains. Where, when I talk about, say, for example, East Coast is known for extensive coastal plains, right? So very easily, somewhere I understand, say, for example, these cyclones can enter. For example, West Bengal, I have lower Gangetic plains. Odisha, I have Utkal plains. Andhra Pradesh, I have Northern Sirkar plains. Tamil Nadu, we have Coromandel plains. But when I talk about the west coast of India, the extension of the plains are very, very less. Right? I have series of, say, for example, state Gujarat, Maharashtra, Goa, Karnataka, Kerala. But among them, only Gujarat have substantial plains. That's the reason. Among the west coast state, you'll be finding Gujarat is more prone to cyclone than the others. Okay. Maharashtra, Goa, and Karnataka, very rarely I'll be having a cyclone because Western Ghats may not allow these cyclones to have its landfall. Cyclones can hit the land, outer margin, but landfall is not ordinarily possible somewhere, as I said, in right west coast of India. Okay. So three very important reasons. All other technical reasons, if you want to write it, you can write it. Why exactly, say for example, the surface temperature, right, is more. Here, simply I am saying it is more continental. Continentality, or it is somewhere. I'll put it. Bay of Bengal is more continental. Bay of Bengal is more surrounded by land. More surrounded by land. Obviously, in lower latitude, if a water body is more surrounded by land, this water body will become more warmer. The water body is more warmer. Obviously, the number of cyclones formed will also be what? Okay. So many facts we have taken it. Number one, as I said, the cyclone formation itself is more in Bay of Bengal than Arabian Sea. 1:3 ratio I have given it. And that too, given the movement, I can say normally it moves towards the poles, towards the west. Normally, I do have an exception. We do have recurving cyclones, but that is an exception. Okay. And extensive coastal plains in the east coast will allow a easy entry for the cyclone to have a landfall, but such extensive plains are not there in the west coast to allow the easy access. Sorry, easy landfall to happen. Okay, right. That's why east coast of India is more prone to cyclones than that of west coast. Right. So somewhere we have answered. Why exactly east coast of India is more vulnerable to cyclonic surge than that of west coast of India? Somewhere we have answered. Right, my dear friends, this is the task of a day. So two more questions I thought that we'll be discussing. Right, no problem. Tomorrow again we have a session. So in tomorrow's session, I'll be covering the rest of the two questions. That is, what are extra tropical cyclones? Tropical cyclones we have taken it. The temperate cyclones are called as extra tropical cyclones. Discuss the weather effectivity induced by them. We'll be discussing about it. Right. Then we'll be talking about, say, for example, weathering as a phenomenon. Right. What do you understand by weathering? What are the different types of weathering? Right. So this question also we'll be discussing in what? So tomorrow's session.